Hi guys, Troy Winchester with Davis Technical College. Today we want to talk to you about tool demonstration. We're going to show you the skills necessary to read the micrometer and other tools necessary to complete Module 4 in your activity. Okay guys, we're ready. Today we're going to go over some of the measuring tools that you need to become familiar with. You should have already learned about how to measure these tools in Module 3, specifically how to use a micrometer, how to read a dial caliper. You should have looked at, as well as a vernier micrometer, a regular outside diameter micrometer. We're going to show you some of the tips and tricks on how to get an accurate part on that sample part that we have over here at the desk. So let's go to the desk. All right, guys, one of the first things that you're going to need to do is you're going to make sure that you can read this OD micrometer. You should have practiced that or reading this tool in Module 3, but now we want you to get the tool and start using it and become familiar with it. One of the first things that you need to do with a micrometer is to verify that it is calibrated. And to do that, I'm going to close the micrometer. Before we were on camera today, I made sure that the anvils were clean by closing this micrometer on a clean piece of white paper, and I slid the tool off, and that cleaned the jaws. But if you look at it, that tool, I'm using the ratchet, a couple of clicks right there, you can see that the 0 is lining up. So that is telling me that that tool is calibrated, okay? One of the next tricks that you can do to learn this skill is go to the gauge pin box and select a random gauge pin. We don't care what size it is. We want you to hold that tool in the proper way. Depending on your hand size and what micrometer you're using, you can use the single hand method where you wrap your little finger through the frame of the micrometer and you can drive the ratchet or the friction thimble either way. Now, if you're using a bigger tool, you often will have to employ the two-handed method where your left hand might be on the frame and your right hand would be on the thimble or the ratchet, depending on what you feel comfortable with. Grab that random gauge pin out of the box and measure that tool. You want to measure that tool until you click it 2 or 3 times. The tool needs to slide off of that pin. Now you're going to go ahead and read that. And this pin happens to measure 480 thousandths. And you can see that we are 475 plus 4 thousandths. A lot of times these pins will measure up to a few tenths undersized. That's not a big deal for what you're doing. Try that again on a different side. Make sure that pin slides off of there. And this is a good way to test your ability to measure a precision part. Then you can look at the part and see, is your measurement on your tool equal to the measurement on the pin? So you'll want to practice that several times. Another thing that you can also do let's go to the depth micrometer. This is a very similar task to what we just did with the OD micrometer. Again, with the tool withdrawn all the way into the body of the tool, it should be flush across here, and this should be 0. If you set that on the surface plate and run it down till it clicks, we're off maybe a couple of tenths, but we're pretty accurate right there. That's showing us that that tool is 0. You can take a gauge block and do the same activity that we did with the gauge pin. Put the tool on top of the gauge block and run the spindle down until it touches the table. Make sure you're not over a hole in the table, that would be bad. A couple of clicks. Now, you can read that tool. A lot of times it helps if you back it up a little bit. Pay attention, we were at 0 on the main dial. If you back it up, you can see that tool, whoops, where was it? Right there, was reading basically 800 thousandths, okay? On a depth micrometer, you're actually reading the numbers that are covered in a lot of cases, so be careful when you read this tool because they do read backwards from a regular micrometer. And the gauge block reads 800 thousandths. So we have tested our ability with a micrometer, we've tested our ability with a depth micrometer. Moving to another tool, this little tool right here is often referred to as a telescoping gauge or a transfer gauge. This tool does not measure anything at all, but it transfers a measurement from inside of the part to your measuring tool, which will be your micrometer. So again, you're going to go over to the cabinet, you're going to grab a couple of different ring gauges. Now, the ring gauge does have the measurement on the back side. Just ignore that for right now. What you want to do is you want to take that telescoping gauge, and if you see this little knob here on the end, that will let the telescoping gauge expand, or it will lock it in position, depending on where you have it. So let it expand, put it inside the hole at a slight angle, okay? It's kind of hard to see that from the vertical shot, but I'll lock that in there. And the tool, you can see, is at a slight angle. Okay, so we're going to put that tool in there to slight angle, and we're going to cam the tool into the vertical position. Do that one more time. Let it expand a little bit, lock it in position, and cam that tool until you go just past 90 degrees. As soon as you go past 90 degrees, the tool basically will lift out of the hole, and it will be an exact transfer of that diameter. Don't put the gauge back in the hole and redo it, because every time you redo it, that measurement will suffer, okay? If you don't feel confident in that measurement, then redo it. Now, you hold the micrometer whichever way it works for you. We're going to close the micrometer, and I kind of keep the micrometer or the tool moving in a little bit of a circular motion so that when I make contact with the tool, which I just did, okay, I look up at that and we read the tool just like we would, 800, and it's past the 50. It's almost to the 875. We can see that because right there is 0, so that would be 875. We were at about 875 minus 1 thou. Let's see how we did. The gauge is actually 875, so we were only 1/1000ths off in that case. Now, doing that on camera and doing that in front of your instructor, all of those things can cause you to be a little bit nervous and get maybe a different reading. So take that reading a couple of times and see. Let's see if we can improve on that. Don't cheat yourself, because knowing the number always influences your reading of the tool. Now, this time I'm getting an honest 874 and, oh, come on, right about 7 or 8 tenths. I would be happy with that, okay? So you want to practice measuring with your telescoping gauge and your ring gauge until you can do that same task with the same degree of accuracy that I'm getting right now. Now we'll give you a little bit of a leeway when we come to test you. We're going to give you some leeway. We're going to let you have maybe a thou, but if you can't measure with your telescoping gauge and your ring gauge to within a thou, then you need to keep practicing that, okay? Not like you're going to use a lot of telescoping gauges, but it's a great skill to establish the proper feel, getting the hand and eye coordination together. Same thing with your depth mic. You want to be able to read that to within plus or minus 1 thou. If you need to, you can double check yourself. If you're wondering how close you are to reading the correct measurement, you can take a tool like the dial caliper and measure that. A couple other things that often come up as problems with new students is the dial caliper can be used for a lot of these measurements, okay? Dimension B on the print and dimension J on the blueprint are showing the same part, okay? Dimension B, for example, is actually measuring the pitch diameter of the thread. So to measure the pitch diameter, you will need to use your thread pitch micrometer. To measure dimension J, you're actually measuring the major diameter of the thread, and so for that, you could just measure with your outside diameter micrometer. Okay, so there's a couple things that you need to be aware of there. A couple other things that people often do wrong with this part is they are asked to measure the width of the snap ring. I'll move back over here so you guys can see that a little better. Measuring the width of that snap ring groove right there. Depending on your tolerance, the tolerance is probably plus or minus 1. So depending on your tolerance, the dial caliper is a great tool to start with, but it's not accurate enough to give us the precise reading that we need. So what you want to do is measure that with your dial caliper and then grab your gauge block. This is the wrong size, obviously, but you would set the gauge block in that hole or that slot and verify that measurement. Another dimension that is often hard to show students how to measure is this dimension here, which is dimension Q, I believe it is on the print. Measuring that distance from the face of the part to the beginning of the snap ring groove. This is about the only tool we have in the shop that will accurately measure that tool, or measure the part, excuse me. So you got to be careful when you're measuring that particular dimension. You want to make sure that your calipers are held in the proper way. You want to make sure that you wiggle the calipers back and forth, make sure you get the same reading, measure it in 2 or 3 different spots. Okay, I'm getting about 351 thousandths on this particular part. If I was to measure the snap ring again, I'm getting about 137. Yeah, 137. So I would double check that with a gauge block that was that size, and I would see if it fit or did not fit. A lot of times when students are measuring the depth of the hole, which is letter H and letter M, they will measure to the very bottom of the hole, the very center of the hole. And if I just measure that dimension H right there, I get a number of 868 thousandths. But if I measure with the square side of the tool. There's a 90-degree side and there's a side with a step on there. If I measure with that step and keep that step up against the square wall, I get a much better reading, and now I get a number closer to 648 thousandths, okay? Because I'm measuring to the shallowest portion of that hole. The same thing applies to dimension M. One last tip on using your dial calipers. Let's see if I can do this here. If you're going to measure the length of a feature, you'll notice I have the square end against the tool. Well, if I use the square end against that shoulder right there, that shoulder has a radius in there, and that tool is not going to fit into that radius, and it's going to kick that tool out. And I'm exaggerating it right now, but it's kicking it out a few degrees, which is going to make that measurement longer than it really is. If you'll use the other side of the tool that has the cutout in it, if you use the other side of the tool, now that cutout or that radius does not affect the part, and we get a much more accurate measurement. We're getting somewhere in the neighborhood of 1 inch 756. But if I measure the other way, the wrong way, and I'm going to exaggerate it just a tiny bit, 1 inch 750, almost 60. So you're getting a bad measurement by doing it that way. I think that's all of the really tough parts of that blueprint. If you guys have further problems or questions, please see your instructor. We'll be happy to go over any of these parts with you, but we want you to come in here and practice. We want you to get your hands dirty, so to speak. Use the tool, measure it. It's just like learning to ride a bike. You've got to do it. We've taught you how to do it. We've shown you videos. Now we want you to come in here and practice in a controlled environment using features that you do know the size of to double check yourself. And then you can continue on with the next module. So again, guys, thanks for your attention, and please see your instructor if you have any questions. Thank you.